Welcome to The Explainer. Today, we're jumping right into a company called TETRA, and honestly, they are completely rewriting the rules of how software interacts with the physical world. Instead of the brute force, energy-hungry tech we're also used to, they're using incredibly elegant mathematics to build a true solarpunk reality. And when I say solarpunk, I mean a future where our digital architecture is as lean, efficient, and harmonious as nature itself. We're talking about moving entirely away from the massive industrial waste that currently powers our internet. To understand why TETRA's mission is just so vital right now, we really have to face a staggering reality. $1.7 trillion. Let that sink in for a second. That is the amount the world is projected to spend on building data centers every single year by 2030. And the growth of that spending, it's absolutely explosive. It jumped an unbelievable 57% last year alone. Basically, we're in this frantic race to pave the earth with massive, energy-draining infrastructure. We're essentially treating data centers like the polluting industrial smokestacks of the modern era, all just to keep our digital lives running. TETRA's own investors actually sum up this deeply flawed anti-solarpunk cycle perfectly with a pretty sobering thought. They said, we build it, we power it, we cool it, and then we throw it away and do it again. I mean, we are trapped in this endless loop of industrial waste. Historically, because our modern software has been, frankly, pretty inefficient and bloated, the tech industry's only solution has been to just brute force the problem. We just throw endless mountains of rapidly decaying hardware and massive amounts of electricity at it, just to make it function. Well, TETRA is breaking that destructive cycle, starting right down at their core philosophy. You can actually see this perfectly in their emblem, the K4 tetrahedron. Now, in mathematics, that's the smallest complete graph. But it's also this perfect organic metaphor for their entire solarpunk vision. It's all about using natural mathematical truths to eliminate excess and waste. The solid body represents the data, and the edges are the connections, representing performance as motion and mathematics as form. It's quite literally about doing the absolute most with the absolute least. So how do they mathematically achieve this kind of extreme biomimicry? It comes down to a breakthrough they call collapsive architecture. The crucial point here is this. Instead of expanding outward, devouring more physical real estate, drawing more and more power from an already strained grid, and mining more silicon, they fold the requirements inward. I want you to picture taking a massive, hot, roaring warehouse of servers and just collapsing all that heavy, polluting machinery down into pure, highly optimized code. It fundamentally shrinks the time, the money, and the hardware needed to run the world's data. To really grasp the sheer magnitude of this architectural shift, let's compare a traditional cloud cluster to a single, everyday commodity laptop. Normally, if you're running complex analytics on a massive web of, say, 172 million interconnected data points, think of a sprawling global social network, you'd need an entire server farm. That means massive amounts of energy and constant, intensive cooling. TETRA is taking that exact same massive cloud cluster workload and executing it locally, entirely on just one standard MacBook Pro M4. It's kind of mind-blowing. And this isn't just theoretical, by the way. It's backed by rigorous industry standard testing. When executing these massive social network benchmarks on that single laptop, TETRA required less than 8 gigabytes of peak RAM. To put that into perspective, that is less memory than most smartphones in your pocket right now. They essentially replaced a room full of heavy machinery with the computing power of a phone. And the best part? They didn't cut a single corner to get there. Every single complex query returned perfectly correct results, 0 errors. Plus, they accomplished this extreme efficiency without sacrificing even a fraction of speed. In fact, the performance is just astounding. Short data reads average around 38 milliseconds. That is literally faster than the blink of an eye. And even complex multi-layered queries, like discovering mutual connections across millions of users, take less than a third of a second. Shortest pathfinding, just 4 milliseconds. They are delivering instantaneous, incredibly complex discoveries, and they're doing it without ever needing to ping some energy-hungry data center hundreds of miles away. Now, this radical departure from the status quo actually stems directly from the unique DNA of the team itself. Yes, of course, they have brilliant software engineers, data scientists, and math researchers. But the company's leadership brings deep foundational backgrounds in philosophy, psychology, and even human-centered design drawn from the music industry. They recognize that databases ultimately dictate how humanity interacts with the digital world. So they aren't just engineering systems. They're architecting a sustainable, human-centric vision of technology that actually serves society.
And what's really cool is they've hard-coded this ethical stance directly into their legal structure. As a public benefit corporation, their actual corporate charter explicitly mandates building technology that, and I quote, leaves the world better than we found it, consumes fewer resources, and emits less carbon. This isn't just some greenwashed marketing jargon designed to make a tech company look good on paper. It is a legally binding commitment that they hold above quarterly profits, making sure that authentic, sustainable innovation remains their absolute North Star. This entire philosophy permeates even their visual design system, which they call the constellation. It visualizes their data infrastructure not as cold, dead machinery, but as a living ecosystem. In this system, warmth is strictly reserved for motion. So a warm coral color signifies living pulses traveling along the data pathways, while the static elements remain cool and grounded. It perfectly captures that solar punk ethos. Highly engineered and mathematically precise, sure, but also fundamentally alive, organic, and beautifully in tune with its environment. Which brings us to a really critical crossroad for our digital future. For years, we've just sort of accepted massive energy extraction and e-wastes as the unavoidable cost of doing business in the digital age. But TETRA proves that mathematically elegant, true solar-punk solutions actually exist today. Solutions that are capable of running massive, complex systems instantly on just a tiny fraction of the hardware. So we really have to ask ourselves, is the future of technology about endlessly building bigger, hungrier machines, or is it simply about having the courage to think better? Thank you for joining me on this explainer. I hope this leaves you inspired to rethink what's possible when we replace brute force with beautiful math.